Hello everybody. So in this video I want to go through some information about naming alcohols with you. Alcohols are going to be our next functional group that we're going to be looking at. And so in order to do so, I want to show you a couple of different functional groups. Some of you've seen before, some of them you haven't seen before. So you can see the video here is called Naming Alcohols. But before we get to that, the first thing I want you to be able to do is to actually recognize when you do or don't have an alcohol. So alcohols, ethers, and phenols are compounds that in some ways have some similarities. The thing you want to make sure that you can recognize is, when do I have an alcohol? Alright? And you have an alcohol when you have a carbon bonded to an OH. Now that's similar to phenols though. When we did our aromatic compounds, about naming those, we saw that phenols are very specific. Phenol is a benzene ring with an OH on it. So this is a phenol. In fact, this is phenol itself. So it's important that you understand phenol is not the same as an alcohol. Alright? Just as this is a phenol too, even though there's an extra methyl group. There's an OH coming off a benzene no matter what else is there, so that's a phenol. Notice there's no other benzenes here, so there's no other phenols. We have two compounds with oxygen, carbon, oxygen, hydrogen, carbon, oxygen, hydrogen, and then here we've got oxygen between two carbons. These are the alcohols. So the dominant functional group of an alcohol is the OH. For the ethers here, you know oxygen only makes two bonds. So we don't have any OHs here. These are ethers. Now as far as naming ethers go, these are really simple, but we're going to leave this until a subsequent video. For today we're going to be focusing on naming alcohols. Alright, but before we do that, I want to share with you one characteristic of alcohols and ethers. Alright, if you look at these two, I'm hoping everybody can see they both have two carbons in them. They both have, if we look at this, that's a CH3, that's a CH2, there's one hydrogen there, so 3, 5, 6. 3 hydrogens here, 3 hydrogens there, that's 2 CH3s, and they both have one oxygen. So both of these have the same molecular formula but different structural formula, so these are constitutional isomers. When you compare alcohols and ethers that look very similar from a molecular formula standpoint, you'll find that the one characteristic that's very different is their boiling point. Boiling points of alcohols are very high. Boiling points of ethers are very, very low. All right. Ethanol. This is ethanol, the alcohol that you'll find in beer, in moonshine, or whatever you choose to drink, or Jack Daniels, or whatever. Something like that. The boiling point of ethanol is going to be round about, I don't know if this is exactly right, but it's round about 80 degrees, I think 80 degrees C. The boiling point of, this is called dimethyl ether, is going to be less than room temperature, less than 25 degrees C. So notice that even though these two have very similar chemical formulas, their boiling points are way different. And the only thing, there's only one reason for that, and it's this. This OH bond. When you have two molecules of alcohol, they can bond to each other like this, and there's interactions that these guys can have. These are called hydrogen bonds. I know you guys have heard of these before. You'll have heard of them in your biology class. Hydrogen bonds are very strong interactions between two molecules of alcohol that you can't have between ethers. That makes alcohol boiling points way higher than ether boiling points. Anyway, that's a bit of an aside. What we want to be talking about is naming alcohols. Okay, so we're going to focus on naming these. As far as naming alcohols like these guys, we name them with a small variant on the alkane naming system rules that we've seen before. Naming phenols is actually much more simple. We just name them as a derivative of phenol. So we don't need to worry about this guy because it's just phenol. When we talk about naming this guy though, this part of the structure tells us it's phenol, and then we have a methyl group. So we have methyl phenol. However, we need to understand where the methyl group is relative to the OH. The OH group takes precedence, mainly because of the oxygen, so it's given carbon number 1. Therefore, the methyl is carbon number 4 to it, so you could call it 4-methylphenol, or if you chose to, para-methylphenol. Whichever of those two names you choose is fine. That's how you name phenols. Now, for naming alcohols, if you remember the 1, 2, 3, 4 carbon chain naming system, methane, ethane, propane, butane, all that stuff, it is exactly the same here. So, a 2-carbon alcohol, it's based on the name ethane. But to name an alcohol, we simply lop off the E and stick OL on the end to signify an alcohol. Therefore, this becomes ethanol. There is no need for us to give a number here because there's only 2 carbons. The OH is going to be on the end carbon however you draw it out, so it's ethanol. When we come to this guy though, there's 4 carbons here, so that name would be based on butane. But because it's an alcohol, it's going to be butanol. Here there's 4 carbons. There are different positions where the OH could be. It could be on the end, which in this case it's not, or it could be on carbon 2. So we call that 2-butanol. And we use that to differentiate it from this. This is also butanol, but this is 1-butanol. Alright? Now for alcohols with the OH coming off a ring, it's the same naming system as before. Butane is 4 carbons, so therefore cyclobutane will be 4 carbons in a ring. I would write the E here because it's an alcohol. We're going to lop that off and stick OL on the end. Cyclobutanol. So essentially these have exactly the same naming conventions. So when we get to more complicated alcohols, it's exactly the same idea. You remember, when we have a long chain like this, we've got to figure out, well, where's the longest chain? And it's got to be the longest chain containing the carbon bearing the OH. So we can see the longest carbon chain looks to be this. 1, 2, 3, 4, 5, 6, 7. If we go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So our longest carbon chain is 7. The OH takes precedence over everything else, so we want a number from the side where we encounter the OH first. So in this case, we're going to get a number from the right. And then we name the substituents relative to that OH group. So 7 carbons is heptane. Therefore, 7 carbons with an OH is heptanol. Heptanol. Now the ol is on carbon 2, so therefore we call it 2-heptanol. If we didn't have these 2 substituents, that's what the name would be. But we do have these 2. We've got an isopropyl and a methyl. You guys would know iso, I comes before M, so therefore isopropyl, methyl. Alright. The isopropyl's on carbon 4. I don't have enough space to write this out in a line here, but 4-isopropyl, and then 5-methyl. Just remembering hyphen between each number and letter. Alright, 4-isopropyl, 5-methyl, 2-heptanol. Let's come down to this one. We'll do the cyclic one in a minute. What's the longest carbon chain here? Well, it's 1, 2, 3, 4, 5, or counting from the left, because you encounter the OH here, it's 1, 2, 3, 4, 5. Now 5 carbons, of course, is pentanol, or pentane, because it's an alcohol. Alright? It's going to be pentanol. The OH is always going to take precedence over every other functional group we've encountered so far. So that means the chlorine is just going to be a substituent. Just as the methyl here is going to be a substituent. So if we just number our carbons, 1, 2, 3, 4, and 5. We're just going to name our 2 substituents as substituents and stick them on. Now we know the alcohol up here, it was on carbon 2. Here it's on carbon 2 as well, so 2-pentanol. But I know I've got a chloro on 3 and a methyl on 4. C comes before M, so I'm going to do my chloro first. 3, chloro, 4, methyl. Okay, I have a bit of a gap here, but whatever. 3 chloro, 4 methyl, 2-pentanol. That's the way that works, just following the same naming conventions we've seen before. Now, for this guy in a ring, if you remember, this was a 4-carbon ring, cyclobutane, so cyclobutanol. Here, this is a 5-membered ring, so therefore cyclopentanol. So I'm going to write that here, cyclopentanol. cyclopentanol. All right. Now notice what else we have coming off that carbon chain. What do we have coming off there? Well, we have two methyls. All right. And whenever we're naming things in a ring, because there's no specific start or end point, we have to know where to start counting carbons, and we always count starting at the carbon with the highest substituent, which in this case is the alcohol. So therefore your OH carbon in a ring is always going to be carbon number 1. And then it's just a case of knowing whether you count round left or right. Well, we want the two lowest possible numbers for our methyl substituents. If we count round clockwise, we get 2 and 4. If we count round counterclockwise, we get 3 and 5. So we make sure that we count round, in this case, clockwise. So if we have two methyls, we need the prefix di to say we've got 2. Methyl, of course, being the name for the methyl group, and 2 and 4 for the location. So 2, 4, dimethyl, cyclopentanol. We don't need the 1 here because we understand that 2 and 4, if we understand the 2 and 4, that means relative to the 1 here. So 2,4-dimethyl cyclopentanol. All right. And that is how you name alcohols. All right. It's simple as that. All right. Thank you.